have a box in the scene, but what if we want to have many boxes? Should we copy the previous one all the time? What happens if you decide to change one attribute of the box? The problem is that when you copy all of them, you need to spend some time to change the attributes of each. Moreover, instead of having a box in the scene, sometimes you just want to create the box from in the runtime. Therefore, we need to learn the concept called prefab. A prefab is a reusable game object template that you can create, configure, and store in your project. It helps you to design complex game objects and reuse them without having to recreate the game object from scratch. Prefabs are most useful for objects that appear multiple times in a scene or across multiple scenes. Let's make our cube a prefab. First, we will create a folder in the project. And name it Prefabs. This is optional, but it is good to organize, since when the project gets bigger, it will be easier to operate through your elements. Therefore, we have separate folders for scripts or prefabs. Now in the hierarchy panel, select the cube we created earlier. Drag the cube from the hierarchy panel to the project panel into the prefabs folder. This creates a prefab asset in your project. You will notice that the cube in the hierarchy now has a blue cube icon, indicating that it is a prefab instance. Now that we have our prefab, let's see how it works. Select the prefab in the project panel. In the inspector panel, you can modify the prefab's properties. For example, change its size. Notice that changes made to the prefab in the project panel will be reflected in all instances of that prefab in the scene. Let's demonstrate how editing the prefab affects all instances. We will take it back. Create a few instances of the prefab by dragging it from the project panel into the scene panel multiple times. Run the game to see what happens. We can see that they all fell with the gravity. If now we want to deactivate the gravity, we can just change it from the prefab. Let's run again. We can see that now they are floating. Since we have a prefab now, we can delete all our cubes in the scene without worrying about it. Anytime, we can use the prefab again. Now that we understand prefabs, let's move on to creating an object spawner with input. We will write a script that instantiates the prefab cube whenever the game starts. Firstly, in the project panel, enter the folder named scripts, which we have created in previous lessons. Inside the scripts folder, create a new C# script. And name it spawner script. Then attach the spawner script to an empty game object in the scene. Let's create an empty game object. And name it spawner. Now we can attach our script to this game object. We can now open our script with double click. In the script, we first need to have a prefab so that we can spawn it in the scene. For that, there is a field called the public field. We can start by writing public GameObject cubePrefab on top of other functions. And it allows us to assign the prefab from the inspector panel. This makes the script flexible as we can change which prefab to spawn without modifying the code. From now on, we can use this cubePrefab variable to instantiate the assigned prefab from Unity. Now let's talk about the instantiate function in Unity. This function is used to create a copy of a game object or a prefab. The basic syntax of the instantiate function is instantiate parentheses original, comma, position, comma, rotation. Here, the original is the game object or prefab you want to duplicate. The position is where you want the new object to appear, and rotation is the rotation you want to apply to the object. We will write this code block inside of the start function. Instantiate cubePrefab, comma, new vector tree, parentheses 0, 0, 0, comma, quaternion dot identity, and we will close the parentheses. Let's analyze this one by one. Instantiate is the function called to create a new instance of an object. cubePrefab is the original prefab we want to instantiate. In our case, it's a cubePrefab that we have assigned to the inspector. New vector tree 0, 0, 0 creates a new vector tree structure representing the position in the 3D space where the new cube will be placed. The coordinates 0, 0, 0 mean the cube will be placed at the origin of the scene. Quaternion.identity represents the default rotation, meaning no rotation is applied to the new cube. The cube will be instantiated with the same orientation as the prefab. Putting it all together, when the game starts, the start method is called and the instantiate function creates a new cube at the position 0, 0, 0 with no rotation. This allows us to dynamically add objects to the scene with scripting. Let's save it with Ctrl S and go back to Unity. Before testing, we need to define the prefab to the script so that it will know which prefab will be initialized. To do that, select the spawner game object in the hierarchy. In the inspector panel, assign the cubePrefab to the cubePrefab field of the spawner script by dragging. Save the scene with Ctrl S. Run the game. You can see that a new cube is instantiated when the game starts. We have learned about prefabs, how to create and edit them, and how to use a script to instantiate them dynamically. These concepts are essential for building interactive and dynamic scenes in Unity. Feel free to experiment further with the prefab properties and the spawner script to create more complex behaviors. For example, if you decide to put this instantiate function in the update function, what do you think will happen? First of all, please do not try that. As you remember, in the update function is called 1 per frame, which means it runs continuously throughout the game. If we put the instantiate function inside update, it will attempt to create a new instance of the cube prefab every single frame. So the most probable outcome is unintended and chaotic behavior, making it difficult to control and predict the game state. Moreover, it can lead to serious performance and memory issues due to its high frequency of instantiation, which will most likely to cause crashes or freezes. Therefore, try to prevent doing that and find alternative ways to solve your problem. You can check coroutines if you are interested in coding in the update function.